With Doubtnut, get instant video solutions to all your maths, physics, chemistry, and biology doubts. Just click the image of the question, crop the question, and get instant video solution. Download Doubtnut app today.
Find the pressure of air in a vessel being evacuated as a function of evacuation time t. The vessel volume is capital V, the initial pressure is P naught, the process is assumed to be isothermal, and the evacuation rate is equal to capital C and is independent of pressure. Let's start by writing the ideal gas equation. PV is equal to nRT. Now, let me bring all the constants, that is the number of moles, that is the temperature, volume, and R to one side and pressure to the another. Now I can write the number of moles in terms of mass. So the mass upon molar mass R T V P. Now let's differentiate this equation with respect to time. So dP by dt is equal to RT, V and M are constants, so can be brought out dm by dt. Let's mark this as equation number 1. Now let's assume that the amount of air that is being thrown out of the vessel in 1 unit time is given by U. So U is equal to V into M n minus 1 minus Mn upon M n. So let's mark this as equation number 2. What I mean by Mn minus 1 is basically the mass of the gas inside the vessel at the time t, and by Mn I mean mass of the gas inside the vessel at t plus some time delta t. Now, as given, the evacuation rate is equal to C. So the evacuation rate can be written as C is equal to U upon some time delta t. This is equation number 3. Now let's substitute the value of U into equation 3. So 1 upon delta t. For U, I will have to write V. M, I'm replacing Mn by Mt plus delta t. And let's get a minus common out of the bracket. So minus Mt plus delta t minus Mt. Let's write this down in a neat and clean manner. Minus V Mt plus delta t minus M at t upon delta t and Mt plus delta t is equal to C. Now we are considering delta t to be a very small amount of time. So what I can do here is I can apply a limit of delta t tends to 0. Mt plus delta t Mt plus delta t minus Mt upon delta t. Now if you notice, this expression that we have just found is basically the definition for derivative. So I can write this as dm by dt. So C is now equal to minus V. For delta t tends to 0, I can replace M simply by M and times dm by dt. Let's mark this as equation number 4. Now let's look at the equation number 1 that we arrived at earlier. In equation number 1, we have a relation between dp by dt and dm by dt. So what I'm going to do is I'm going to replace dm by dt by its value from the equation number 4. So dp by dt is equal to RT by Vm, RT by Vm. Let's put the value of dm by dt, that would be minus mc by v. Now, if you remember the ideal gas equation, that is PV is equal to mmRT. From here, I can get the value of P in terms of the RT, V and M. That would be mRT by mv. And in the equation, let's say this is 5. In the equation number 5, if I rearrange the articles, I can get minus C by V times mRT by mv. So this can be written as capital P, or the pressure, minus C by V times P. Now all that is left is to solve this differential equation. dP by P is equal to minus C by V dt. And in the question it is mentioned that the initial pressure is P naught. So P naught, capital P, dP by P is equal to minus C by V, because these are constants, integration 0 to T dt, which gives us ln P minus ln P naught is equal to minus C by V T, which gives us ln P by P naught using the property of log equal to minus C by V times T. You can write this in a different manner if you like. That would be P by P naught is equal to e raised to the power minus C by V T, which means P is equal to P naught e raised to the power minus C by V T. And we have a relation between pressure in terms of time as the question asked.
For class 6 to 12, IIT JEE and NEET level. Trusted by more than 5 crore students. Download Doubtnut app today.